Everybody, don't have any announcements that I know of. Kathy, do I need to announce anything?
We are recording this meeting. The recording just began.
Okay. I'm going to announce that this is a recorded meeting, so you are being recorded, and thank you for your attendance today. Since we're getting a little bit of a late start, we're gonna skip introductions and you want to ask Jude for his update now? Jump in right away. All right, Jude, we're going to pass the mic to you and see for an update here. You ready, sir?
Yes, sir.
Oh, you are ready. You've been patiently waiting.
Not my strong suit either.
Of course not. Go ahead, sir.
All right. This is a report out on the task force meeting February 20th of this year. I want to first off thanks all the task force members for all their ideas and input on what we're working towards this fiscal year. I also want to thank Kathy Brooks and Laura Higgins for working so hard trying to herd the cats of the task force meeting. Unfortunately, even though Laura had given us several dates to work with, nothing to work in my semi-retired calendar. So I was unable to attend. So if you have some in-depth questions on some of the information I'm getting ready to give you, you'll probably need to refer them to Laura, and she can give you more information, probably via email. It'd be the best option. But the task force meeting discussed several major categories. I'll list the major categories first and then just go into a little bit of it. The first major category was what the outreach messages and themes needed to be, the outreach information elements related to those messages, the materials to be produced that would support those, the dealership distribution and involvement ideas, which is a key theme of this task force this fiscal year, and any other ideas and comments you may have. So for the outreach messages and themes, the major outreach messages should be training and licensing, which is critical, and helmet and gear, which is, our last bastion of defense if things go wrong. So under training and licensing, should be three parts to the message. First is the necessity to have a license, the training required for a license, and information on where courses are available. Some other items discussed were, if you are going to buy a license, buy a motorcycle without a license, that's the necessary step 2 before the step 1. And of course, the step 1 is to learn how to ride the motorcycle, which is the real value of a lot of the basic rider courses that are available. It's not just the instructional information that might help save your life, but also helps folks who have never ridden a motorcycle before determine if motorcycling is for them prior to purchasing a machine. Under helmet and gear, a lot of information on what the message should be, and of course, the main crux of that message should be please wear a helmet. The rating on the helmet seems to be a little bit of a item of concern for the task force. A lot of DOT helmets, primarily in the United States, but of course the ECE designations are a little bit different, and those helmets are available. So there's some question about European standards versus DOT standards, and what helmet you should have. If it meets the DOT requirement, that's going to be a legal helmet in the United States. The reasons to wear a helmet were a point of discussion, and any ideas that you might have that would be good reasons to present to to individuals involved in motorcycling to wear not only their helmet, but all their gear are always welcomed. Any type of slogan you might have that you think would be effective would be good information. But also, information on a brochure about what a DOT approved helmet looks like, what the DOT sticker looks like, and on information on how to pick out a good helmet would also be good information on a brochure. Now, I know we give that information in a lot of basic rider courses, but there's a lot of riders out there that have a Class M license that don't know a whole lot of information on how to pick out an appropriate helmet. On outreach information elements, under the heading of training and licensing, uh, information about how to get to the TDLR site, about how to pick schools in their area, any use of data on unlicensed riders, and I believe the data is available through TTI because research has been done, and that's information we've been pushing out for quite some time. Um, and there, it's interesting. A lot of people look at that data because it's such a high percentage, especially in fatal crashes, of unlicensed riders. That's not a direct correlation between um, the number of riders that are out there riding unlicensed. It is a direct um, information on the number of riders who are killed or seriously injured who don't have a Class M license, which points to the effectiveness of training, I believe. Um, Maybe more focus on financial penalty of riding unlicensed. That's a little bit of a slippery slope. Um, just the same as I've heard a lot of folks talk about the possibility of impounding motorcycles when a rider is caught without a Class M license. I say that's a slippery slope because now you're using uh, um, some extension of laws and regulations in order to penalize motorcycle riders more than you would penalize a car driver because it's not normal uh, police activity or part of their policies to impound vehicles when a driver is caught without a license. If the agency has some kind of policy that they are to take drivers before a magistrate forthwith, then they could do the same thing with a motorcycle rider, but that's just not agency policy in most places. Um, we talked about court fees being different in different locations and jurisdictions. This is also true. When I was with TxDOT, I put together a training PowerPoint for court judges and their administrators uh, about the value of requiring a rider to take the course to get their Class M license rather than just give the rider a fine amount. I think there's greater value to society and certainly to the rider if we get them trained rather than just go forward with with fines. So I hope that will continue and we'll make some improvement there. It would give us some consistency in the way jurisdictions, court jurisdictions would handle riders who come in with a citation for no Class M license. But also, I think it would probably help uh, with our terribly bad motorcycle crash and accident statistics. Helmet and gear. When we when we talked about helmet, the the main um, courses of discussion is how manufacturers certify the helmet as far as the DOT approval and how we can tell if a motorcycle helmet is DOT approved. Of course, we've all seen the DOT sticker. There's a Federal Motor Carrier Safety number assigned to that DOT sticker. Of course, unfortunately, there's a lot of fraudulent stickers out there, just as much as there are, less than DOT approved helmets. And then there was also discussion on the fitment of helmets, including, the different shapes. And those different shapes are different from manufacturer to manufacturer, which means really brick and mortar trying on helmets is the best way to get a helmet that fits you properly. Um, and I think that's something that needs to be included in the brochures. And I think that would help with dealership involvement as well, is to make sure riders understand that if you want to buy a helmet that really fits you well, you need to try the thing on first. Under the heading of materials, we talked about displays, paper goods, social, online, electronic, and other materials. Um, the displays split off into different types of displays that could be used, including spinners, window clings, and table toppers. Under paper goods, which TTI has done for years and years, um, multi-use brochures, coloring and activity books for kids and Maurice. Um, Compare the pictures worksheet, which I think is an interesting idea, because it focuses or makes younger kids focus on the differences. Brochure information printing onto something more useful. That's an interesting idea. So a more useful and durable item that the brochure information could be printed on is an interesting idea. And social, online, electronic, I think TTI does an exceptional job currently with the safety messages. I know I get them on my Facebook feed all the time, and Grad are happy to pass those along to folks involved in motorcycling. And I'm hoping that members of TMSC are doing the same thing. Other materials, window clings or motorcycle windscreen clings, as long as they're not too big, um, and impact safety. Magnets for toolbox and refrigerators, postcard size magnets, window cling or paper clings with suction cups. Stickers are very popular. Um, I remember TTI used to make a TMSC sticker that was a very good looking sticker, and I think I had that on all my motorcycles. So um, I would hope to see that again if those aren't currently available. I've not seen one in a while. Dealership distribution and involvement ideas. This is something really at the heart of what we want to focus on this year, is trying to get a greater amount of dealership involvement and distribution of these motorcycle safety related items. Uh, one of the um, one of the items discussed was that dealerships can really influence the choice to take the course and get licensed. And does the salesperson care about the customer to be safe and legal? I hope that's a focus. Of course, the primary focus of the dealership has got to be the sale of the machine. But I know personally a good friend of mine was in the sales business for a very short time, and basically got fired because uh, he didn't want to sell a customer a brand new 1 liter sport bike who had never ridden before, and had suggested he buy a smaller sport bike, and got fired over um, that thought process. So that's probably a isolated kind of occurrence, and I hope so. But the question becomes, are we really trying to push any machine out the door to customers who are very limited in their ability to ride. I'm not going to fault a dealership for doing that because it's their primary focus is to sell machines. But um, I hope that there is within the dealership network a concern also about building return customers and safe riders. So that's why the focus this year is to try to get more dealership distribution and involvement. Um, there was also discussion on a contest in Texas of salespeople who had 100% of customers who already had or got their Class M license within a set period of time. I think that's a very good concept. Um, but it, also involves, some administrative kind of involvement. On one day, 1 week added a sticker to a purchase of a coffee or Starbucks. uh, Finding champions in the dealerships. I think that's also a very good idea, and getting those champions involved in the TMSC, I would add. Um, Returning rider upgraded motorcycle sale, and a conference within the Texas Motorcycle Dealers Association with dealer principals to be champions. So those are all very good concepts, and I hope we can ultimately get more dealership involvement. Additional ideas that were discussed is uh, driving schools provide information about motorcycle licensing. I can tell you that the driving schools currently have to push out so much curriculum. It's tough to get additional information out there, and I would hope maybe this could happen, but I would be a bit skeptical. Um, Rocket science video for drivers. I have not seen that particular video, um, but anything that we can get related to motorcycle safety added is a good thing. Incentive to take surveys up to take the course, and I believe Cody is working on that project now. So I'm sure as that progresses, Cody will give us an update. And CLC and I talking points to turn into a social media video. That might be very interesting. Um, some of the talking points discussed were rider tips relative to grass clippings, why motorcycles or a motorcycle does, what they do in traffic and the reasons for it. A lot of drivers don't understand what we're doing relative to lane positioning and a lot of other things that we do. And some other tips for drivers. Those are all very informative, and the proper venue for those are motorist events, which TMSC does quite a bit, and so it'd be a good information to pass on to motorists. Um, Specific items support to dealers to address alcohol and riding at their events. That's one of the key issues that we want to see addressed relative to motorcycle dealers this fiscal year, is to see if we can drop off some of these alcohol related events. I think it just sells a bad message relative to the motorcycling culture. And ride your bike to work day. Police escorts, invite media, riders to get their aspects on safety, promote the early for the June dates and weeks leading to events on the motorcycle ride to work day. There's also an item here about TxDOT setting up a booth to promote safety, including a designated driver, so it's a motorist event. And those are the items that were discussed. If you want any additional information on those, again, you'll need to discuss that with Laura, since I was unable to attend the event this time.
I will jump in there if y'all can hear me. Can you hear me?
Can y'all hear Kathy okay or not?
All right. Jude mentioned events, motorcycle events or motorist events. The Texas Department of Transportation has put out a mandate to all of the 25 district traffic safety specialists, that they are required to do at least one motorcyclist safety, attend one motorcyclist event to promote safety. So if you are not aware, they don't know where to go or what to do, many of them. So if there's events going on in your area, in your county, reach out to either one of us or to your local traffic safety specialist. If you don't know how to get in touch with them, get in touch with us. We'll make that connection for you and help them get messages out to those motorcyclist events as well. Thank you.
Thank you, Kathy. Next on your agenda is, want to remind everybody that 2024 Motorcycle Safety Coalition Safety Awards nominations are open till April 15th. So just like your taxes, you need to get these done and turned in. There will be no refund, but the other thing is you won't have to send in a check either. So there is a good news for that part. Kathy just mentioned the traffic safety specialist coalition presentations. Do you have any of those scheduled or anything?
I do.
Okay.
I will be in.
Put you on the spot here, sorry.
You love putting me on the spot. What are you talking about? I will be in San Angelo on May 2nd. I will be in El Paso via Teams also in May. And I think I want to say there's one more, Dallas. I'll be up in Dallas area, I think in June.
So if you're in one of those areas, make sure you try to attend that as well. Also a note here that the NHTSA Motorcycle Safety Program Assessment kicks off next week.
We're looking for subject matter experts in any part of the guidelines for motorcycle safety from NHTSA. So whether that's trauma, first responders, law enforcement, legislators, legislator aides, across the gambit, motorcyclist groups, instructors, trainers, schools, anybody we can get to help provide us some information to inform that assessment. Please contact myself or Laura.
Basically, I mean, this assessment is basically looking for what pretty much everything and anything that we are doing in the state of Texas to promote motorcycle safety. So yeah, anything that anybody knows about, please let us know. We'd love to include it. I'll let Kathy, I saw a comment pop in, but I can't handle it from this computer, so I'll let Kathy take care of that. All right. So next on our agenda we have two guest speakers today. We have Jane Lundquist from TxDOT, and we have Nathan Schultz from right here at TTI. I've got Jane on the program first. They're in no particular order, but both of them are here to talk about some of the developments that are happening on the infrastructure end, on the technical end, to improve motorcycle safety in Texas. So I'll go ahead, and I think Jane's going to share her presentation. Let me exit out of this one. And Jane, do you want to try to take over and share your screen?
Sure, just give me a minute here.
Sure.
Okay, can you see my screen?
Can you see it in the room? And we're good on Teams? Yes. Awesome, thank you. You're good to go.
Okay, let me introduce myself. Good morning, I'm Jane Lundquist. I work with the TxDOT Design Division. I've been there since 2001. I've been a motorcyclist since I was 17 years old. That's when I bought my first motorcycle against my mother's better judgment, I guess. I've served on the Federal Highways Motorcyclist Advisory Council from 2017 to 2020. I was a member of the Federal Motorcycle Safety Project that was assigned to TTI, Stakeholder Engagement Group. I am currently participating in a motorcycle pooled fund group And that's a group of 7 states, and we're looking at issues that face motorcyclists. That is in progress, and I am serving on a TxDOT research and technology project. It is regarding the retrofit design of guard fence systems to accommodate motorcycle safety, and that one I think will close out this fall. So let me get onto my information here. Motorcycle fatalities. Well, back up here. Got my screens all messed up. Okay. Motorcycle fatalities. When the MAC looked at the motorcycle fatalities, we had a chart, and it showed the increase in motorcycle fatalities. It began in the 1990s and started to rise. And in 2020, 14% of all traffic fatalities were motorcyclists. This is the highest number of killed motorcyclists since 1975. As I also looked at this chart a couple of years later, I began to question why there were bicycles and pedestrians that were being killed as well. And we have quite a bit of evidence now that we have got supersized vehicles that are showing up on our roads, and these are very large and pose a risk to motorcyclists. When you have a vehicle front that is almost 5 foot by 8 foot, it's like a big brick wall coming at you. And as one writer wrote, it was like a scowling brick wall. So in the past, when I took motorcycle training decades ago, we were warned about big rigs coming up behind us because they have such a huge blind spot and they can't see you. Well, now we have these vehicles and they have huge blind spots as well. So even though the video we watched was about warning us for cars in front of us, that we can see, but it's the vehicles coming up behind us, these large vehicles, whether they're a personal SUV or a personal truck, these pose a threat to us as well. The Motorcycle Advisory Council, we had the direction was that we needed to have people who could discuss barrier design, roadway design, construction, and maintenance, and the architecture and implementation of intelligent transportation systems. The MAC defined 11 areas that were specifically related to infrastructure maintenance and construction that affect motorcycle safety. The pothole issues that we find, open milled road surfaces, steel plates, uneven pavements, gravel and debris, traffic barrel sight distance. Traffic barrels are 1.5 feet diameter and they're almost 4 foot tall, and sometimes they can block us seeing a danger beyond it or a driver seeing us. Raised manhole covers, chip seals, excessive overband crack fillers and joint sealants, and low friction pavement markings, and traffic actuated signals that don't detect motorcycles. The MAC barrier design recommendations, which TxDOT has taken to heart and we are looking at. The problem was that barriers were designed to protect passenger vehicles and large commercial vehicles. And in most cases, motorcycles have never been considered in any kind of a design. And so we have more injuries when we hit these devices. The recommendation was to have a secondary rail system to prevent motorcyclists from sliding under existing guardrail and into support posts. Impact mitigation devices that could be installed on existing support posts to reduce impact force and deceleration, while easier to install on a curved road section than a second rail. New systems are to mitigate impacts for riders in either an upright ejected position or a sliding rider who has fallen. I'm also involved in the Transportation Motorcycle Pooled Fund. In 2021, TxDOT became the lead agency for the Transportation Motorcycle Pool Fund Program for the development and evaluation of roadside safety systems for motorcyclists. This is being done in cooperation with other state DOTs. We have 7 states that are participating with us. Research is being done by TTI. This multi-state team of participants is sharing experience and practice and design to address motorcycle safety solutions. The research needs, we're looking at shoulder widths and applicable side slopes to allow better recovery for motorcycles, passive methods that decrease roadway departure, barrier design for safety, developing guidance to determine locations for motorcycle safety design elements, investigating the geometry of the roadway elements, and signal detection. There was a need to develop an appropriate use of retrofit barriers, and in 2019, TxDOT selected TTI to help us with the roadside guard fence retrofit. So we have been looking at this since 2019. COVID kind of stepped in and it kind of delayed the completion of this research because we just couldn't all meet together, and we had to do the crash testing in various ways. In 2019, we also had the Bridge Division made a design for these nets that we can put up on the concrete barriers. We've had incidents where people have flown over the top of a direct connect barrier from an elevation. And so these are being installed in locations where there has been problems or there could be high risk sites that are going to be looked at. They can't be installed everywhere because the cost would just be prohibitive. But this is an example. We have in the detail that is shown here, we have the bracket that holds it up, and it's like a chain link fence, and it retards the rider from flying over the top. The roadside barrier research that's being done by the design division at TxDOT has taken a look at the barriers that we are proposing to use for roadside. The detail that you see in the picture, that is off of our standard that has been drawn. It's not, these have not been approved yet. I expect this to be approved after the research is done in the fall, but we have come up with a plan to put a cap rail on the top, and there is a rub rail at the bottom underneath the W beam. And we had to go through iterations of angles to mount that so that we would be able to safely retard a rider that's sliding along the roadway. In the pictures here, we've got the barrier cap rail. This is a crash test at the TTI testing grounds. The rub rail shows an ejected rider in an upright position sliding across the rail. And at the bottom, you can see the rub rail. There is a kind of an S-shaped bracket there that helps absorb the impact from the rider. And this is an example of a rider sliding. The rider they have it in the testing ground, they have it defined where they want that rider to hit. And you'll see the orange paint. The rider slides up towards that. They hit it. It causes the spring connection in the back to collapse and absorb that shock. And the rider slides along the rubber rail. The MAC road design recommendations. The problem was motorcycles have unique characteristics and behavior. The word motorcycle is often absent from design manuals and guidance. Cars, trucks, pedestrians, and bicyclists are accommodated in design criteria, but motorcycles and motorcyclist safety need to be accommodated. And the recommendation was to do pavement friction testing using a motorcycle tire where appropriate due to unfamiliarity with motorcycles. Recommended manuals, design guides, and training include specific modules for motorcycle design practice. We recommended that motorcycles be adopted as a minimum reference vehicle design where appropriate in design guidance, and limit bumps, uneven edges, or drop-offs and milled surfaces during construction. In the area of pavement design, Texas is a very aggressive user of high friction surface treatments. These have an exceptional skid resistance. It's site-specific bonded treatment applied to the pavement surface. And since it's highly abrasion resistant, it can last, it has a pretty good lifetime and can last. These treatments are used frequently on our roadways, in particular where we've had crashes in the past because of the road surface. And this is something that can be applied at curves where things are much more difficult to control. We also have what in TxDOT we call it the MUDSID. This is the manual. It's the Federal Highways Manual for signage that we put on our roadways. We're looking for signage that communicates information to motorcyclists and being specific. In particular, we want road condition. We want something to tell us what's coming up in a construction zone. And with the roadside or the sign with the motorcyclist on it, it makes it very evident that they have made a point of pointing this out to a motorcycle rider. The TxDOT Roadway Design Manual, that is under review right now. It's proposed to be released in the fall. And the updated manual, it's the first time we are including a chapter on motorcycles. An overview of the topics that are going to be considered for inclusion are pavement features, roadside features, signage, and other road furniture, longitudinal barriers, shoulders, horizontal curves, intersections, and work zone safety. Intelligent transportation systems. Now, I am not a part of that subject matter experts. I've been in on the conversation, but the conversations that we had among motorcyclists, one of the discussions was having a motorcycle that would make a decision for the rider and startle the rider into a dangerous situation or a crash. So there are some things that need to be considered about how a bike is controlled versus how is a bike seen by other users on the road around them. When I'm on a motorcycle, it's 360 degrees. I have to be aware of what's around me, what's going, what's coming, and left, right. I have to be aware of that. That's part of my job as a rider. So when my bike would make a decision for me, that would be something that would startle me. And so we're trying to find a common ground here and make it more evident, since we have problems with cars hitting us, that they would, because they don't see, drivers don't see us, they aren't looking for us. We need to have a way for the vehicles to be able to see a motorcyclist in their vicinity. Safety depends on a safe ride, and your life is riding on it. Before you ride, check your tires, check your chains, make sure that everything is functioning. You got horns and lights. It doesn't do much good if you have a failure of any system on your motorcycle and you're caught out on the road somewhere and hopefully not injured. So check your ride before you go. Personal protective equipment. Jude laid out quite a few things that are important to do. Helmets are important. If you don't have a full face mask, then wear eye protection, because I've been through some dusty construction zones, and if you don't have something to protect your eyes, you're going to be blinded by the dust that flies through the air. So cover up anything you want to save. Motorcycle safety, when you're riding with a passenger, they can influence the handling of the motorcycle. If you have a new passenger, inform them how they are to ride and how they are to get on and off the bike, so that they can help in their own safety. Riding safety is in the control of each of us who ride a motorcycle. The biggest issues that we have are the highest cause of motorcycle crashes and fatalities. Riders that are riding under the influence of alcohol or drugs, riding beyond the ability and experience with the motorcycle, lack of motorcycle training, because driving a car and riding a motorcycle are two different skill sets and knowledge. Since this is being recorded, I will expect that this presentation will be a part of the meeting recording. And I have a URL there where you can get motorcycle statistics. Very interesting. It breaks it down into the riders, the environmental issues, the gender, fatalities, geography. Anything that you want to look up, it can give you an idea of what has happened and how much each state has. You can do it by state, by individual characteristics. And we are trying to end the streak of daily deaths on Texas roadways. So it's up to each of us to remember the job we have when we are on a motorcycle is to ride that motorcycle and do it safely. And the same in a car. That's our only job. So I want to thank everyone. If you have questions, I will try to answer them if somebody can give me the questions.
Thank you so much. Any questions for Jane here in the room? Yeah. Any online so far? Okay.
I did want to mention, I was glad to hear that they are reviewing the manual, because this research was done several years ago. Even with our construction zone research that was done several years ago. We informed the engineers, but that didn't mean that it got into the manual. So the contractor didn't necessarily see what those guidelines were. So I'm glad to hear that that's under review. Thank you.
Thank you so much. And we'll go ahead and we'll get Nathan set up here. And Nathan, I'll have you come to this one. So for anyone who's seeing us online, we're in a double wide conference room. And when we came in here, most everyone sat on the side that you can't see. So the reason that this side looks like we have an empty room is that everyone's over on that side. But I'll have
I have a question for Jane.
yes.
How can we visually detect when a road is surfaced with the high friction surface treatments? Or consequently also visually identify when a road surface is not HFSD treated?
I don't believe you can make the differentiation by looking at it. It pretty much, it looks like an asphalt surface. So
But it's definitely not chip seal.
no, this is specialized. It's a specialized coating or a treatment that they put on there, and it's going to look like other asphalt. Maybe Nathan has a better, perspective of that. I'm not sure, but I hate to throw that at you, Nathan, but
I think
I don't think there's a visible way to tell.
Thank you.
And unfortunately, I'm not much of a pavement guy, so I don't know if I can really add a lot to that conversation, but it's certainly something worth looking into. Well, good morning, everyone. My name is Nathan Schultz, researcher here at TTI. I've been here about 10 years. I'm actually not a motorcycle rider myself, but I will say my first project when I came out here to TTI, I was undergraduate student at A&M. First project I got put on was looking into motorcycle safety for barrier hardware. So it's been something I've kind of had a lot of interest in since I've been here for 10 years, and something I've been kind of trying to help kind of push the envelope. So again, kind of my background is working on developing guardrails, concrete barriers, kind of different treatments you see on the side of the road, and developing and designing those to be safe for vehicle impacts. And so that's kind of a lot of my background. And again, something we've been trying to look at over the years is, historically, these things haven't really been considered to be designed for motorcycle riders. That's not really been something that's been given a lot of thought to. And so that's something with, again, kind of the past few years, we've been trying to do that. And, through different projects like with TxDOT, as Jane mentioned, our kind of pooled fund mechanism where we're working with a few other states as well, who again are kind of trying to have more consideration for motorcycle users. Again, with that kind of pooled fund, we're not looking at just hardware design, guardrails, barriers, but that is something we're been giving kind of most of our effort and research towards. One thing I thought was interesting that I think Jude was kind of talking about earlier about helmets. We're actually looking at doing some testing on different helmets, looking at all the different requirements, whether it's just the DOT sticker, whether it's maybe tested or kind of considering the SNEL testing. We're also looking at all the different ones on the European side, ECE. So it's been kind of really interesting to see, again, some of the different ways that these helmets are kind of considered. So maybe that might be of interest down the road once we kind of get to running some tests and kind of seeing how the different helmets are made, how they perform in kind of different types of impacts. So just thought I'd throw that out there. So again, I'm going to kind of focus in a little bit of what Jane kind of just hit on a little bit on one of the designs she mentioned, which was for a guardrail system. So we had a specific project with TxDOT. We wanted to give some consideration, design a guardrail system that we might improve safety for a motorcyclist to hit it, if a motorcyclist were to hit it. Obviously, with these systems, it's, as was kind of mentioned a bit earlier, one of the more last lines of defense. So, hopefully it doesn't get to this point, but if it does, hopefully we can kind of make it a little bit safer if a motorcyclist were to hit it. One of the things that kind of gets brought up is, maybe it might be safer if that weren't even there in the first place. Might have more room for a motorcycle rider to recover, if they go beyond the roadway. A lot of times states are putting this in areas where there's something just beyond the guardrail, whether that's going to be like an embankment, some cliff, maybe some trees or objects nearby. And generally speaking, those, aren't going to be any safer than a guardrail. So that's part of the reason, obviously states are putting those in. And so, one of the things that kind of came out recently, I'll kind of touch on this. There's a kind of national project that was done recently by Virginia Tech. They looked at a lot of interesting data related to motorcycle impacts. Again, they focused primarily towards different types of motorcycle crashes with hardware. But they also looked at, again, other things like objects, trees, other things. One of the big findings was, and was kind of alluded to earlier, is that, we see a significant number of fatalities when motorcyclists are impacting guardrails. In fact, the number or the kind of percentage of overall fatalities is higher for motorcyclists than it is for a standard passenger vehicle. And when you think about just the number of registered vehicles in comparison to motorcycle riders, that's just a very large, difference in comparison to, again, a small sample size of motorcycle riders in comparison. So, it's kind of been something that's been identified. Again, kind of from the level of federal highway, they've been really trying to push some different things. As Jane mentioned, there's kind of a number of different safety options and treatments that they're trying to investigate, provide recommendations for. Again, hardware is just kind of one of them that we've been focusing specifically in our group on. And so that's kind of what I'm going to kind of go through. So again, historically what we've done when we're designing guardrails and barriers and other areas, running crash tests where we impacted with maybe a small car vehicle, a pickup truck, trying to see how they interact. And so again, historically, we haven't really considered other types of vehicles. Maybe sometimes, depending on the system, we might go for like a heavier vehicle, a tractor trailer. But we haven't considered other things like motorcyclists historically. And so, everything you see out on the roadway is kind of there, again, designed and intended to safely redirect a truck or a car if it were to impact it, those occupants safe. And so, one of the challenges, if we're talking about designing a hardware for a motorcycle user, I'm sure we could probably come up with something that would be a lot safer than what's currently out there. But, it may not make a lot of sense to just go and kind of take up all these existing designs that are out there, kind of make them just for motorcyclists when we also, have other road users. And again, obviously, the prohibitive. So what we're trying to do with this particular project with TxDOT is take something that was existing design, see if we can kind of modify it, kind of change the design a little bit to maybe have some more consideration for the different ways that motorcyclists might interact or impact a guardrail. Again, I'll kind of hit on specifically, the project we were doing with guardrail, but there are other types of systems out there. Obviously, the kind of main categories are going to be cable barrier, concrete barrier, guardrail. As Jane kind of mentioned, there's been some stuff that's been done to consider concrete barriers. The tendency for those is to see ejection of the rider over the barrier, which can be, kind of significant if there's something beyond the other side that could lead to fatality. And so having maybe some type of containment fence could be beneficial. One of the things we hear all the time, really, at least in the kind of years I've been looking at this here all the time with cable barriers is, those are basically like cheese graters. They're really dangerous, and that's certainly true. I'll kind of hit on a little bit later, but kind of some of the findings, at least with some of the crash investigation, is that maybe not as dangerous, at least in comparison to some of these other hardware types, as maybe is kind of thought or believed. But certainly just another type of hardware that any kind of interaction with that is likely going to lead to some serious injury, potential fatality. So again, kind of just jumping right into that topic. So there was, again, kind of this national study that was done. One of the challenges I'll say that, has kind of been identified is just the lack of significant data when looking at crashes. There's just not a large number, again, just because there's not a large number of motorcycle users in comparison to the type of data we look at for, standard passenger vehicles. But, they looked at some crashes. I think they looked in about 5 different states. What was kind of the significant finding they found is that, when you compare the odds of serious injury for a guardrail to maybe a concrete barrier, the odds were about 1.4 times higher for a WB guardrail crash. So again, that kind of meaning that the WB guardrail is kind of showing that it's maybe a little bit more of a tendency for serious injury. And then on the other side, they found that, the odds of serious injury were about 0.85 times greater for cable barrier compared to W-beam, which essentially just kind of was showing that the W-beam actually seems to be indicating a little bit higher odds of serious injury. And that, could certainly be maybe a little bit misleading, just in the sense that oftentimes I think cable barriers are not installed on curved roadways or maybe other areas where maybe it's harder for a motorcycle to traverse. So a lot of that stuff isn't taken into account. And I think this was just kind of a very initial broad scope finding. So there's probably certainly more to that, but it was just kind of an interesting thing that they found. Kind of again showing that at least from this particular data set, the WB guardrail being a little bit more higher risk in comparison to some of the other hardware types. So that kind of leads into what we're doing with TxDOT, trying to look at a specific design for these WB guardrails. The other thing that kind of plays into how we came about looking to investigate a design is, well, if we're going to design something, how should we consider impacting it? Something I'll kind of touch on later is that there's really no standard for us to follow that says, hey, if you want to design something, here's how you should kind of evaluate it. They looked at the types of different ways that these crashes were occurring. You can have any kind of number of configurations. You stay on the bike, the rider's on the bike, the motorcycle stays, and then you impact the guardrail. Maybe there's some separation prior to hitting the guardrail. And so maybe you have a rider sliding before it hits the guardrail. You could kind of have a rider that maybe impacts and maybe stays on the bike maybe throughout the event. They looked at kind of all these different kind of categories of ways that there could be kind of a potential impact with the barrier. Again, injecting over the other side of the barrier as well. One interesting finding is that about 70% of the impacts were with the rider and the motorcycle upright, all the way up to impacting the guardrail system. So that's kind of a little bit against what's kind of been historically done, particularly with the European community where they do a lot of tests with the rider sliding on its back. So there hasn't really been, from a kind of testing perspective, a lot of consideration for what we consider, kind of call an upright impact. And, you know, kind of what we're seeing, or what was seen in this crash data, is that a large kind of majority of the crashes do occur in this particular category of configurations. But there are other ones we still maybe want to consider as well. Again, as I mentioned, you know, we had this TxDOT project where we wanted to, again, take an existing design, see if we can come up with a retrofit option, modify the design slightly so that we can consider motorcyclist impacts for upright, also sliding, see if there's a way we can improve the safety during those impacts. You know, and then also looking at what we also wanted to look at is make sure that what we modified or retrofitted didn't necessarily negatively influence the design or how the, you know, basically the guardrail worked for, you know, again, those passenger cars and pickup trucks. So not only do we kind of design and test it with the motorcyclists, we also did a couple of tests with standard vehicles just to make sure we didn't see any kind of significant difference in the performance for those vehicles. Again, one of the things they looked at, and they did a very detailed look at the types of injuries that occurred when there were motorcycle crashes with guardrail systems. They kind of worked with a couple of trauma centers with, I think it was in North Carolina. You know, one of the things that they identified as being again, this is specific mostly to the guardrail systems, is basically three main injury mechanisms that occurred and kind of what was the primary cause of those injuries. First one being, you know, obviously with those exposed posts, basically rider entanglement with the posts. Also, again, when you have that maybe upright impact and maybe a rider was sliding along the top, kind of two different types of lacerations occurring from the top of the post itself and the top of the W-beam rail. And so kind of showing here is kind of where I'm kind of have those circles shown as kind of three areas we want to focus on, trying to protect and prevent maybe some of that interaction, engagement, entanglement with some of these items. So again, you kind of see that kind of singular steel post there along the bottom. So that would be, again, more for a sliding configuration, having something that might be continuous and maybe redirect a rider rather than having it kind of catch onto the post there. And then again, thinking about, you know, maybe an upright configuration where you might be sliding along the top, or even if you vault toward the side, you might have some opportunity to kind of interact with these systems. You know, you kind of got those sharp edges from the top of the post. Even those blockouts could probably lead to, you know, maybe some sharp edges. Then of course you kind of have the sharp edge of the W-beam rail itself. So we kind of went into this project in mind, kind of having those three areas that we want to try and address through kind of a retrofit design, see if we could provide a little bit more protection kind of from those sharp edges and kind of blunt objects, so to speak. So, you know, again, kind of the background side is, you know, typically when we design these systems, we want to run crash tests, you know, kind of laboratory settings. You know, we have all these aprons out here on these kind of runway aprons where we run a lot of crash tests, just to make sure that, you know, before, you know, states are installing on the roadside, we have some confidence about how the design is going to work. Again, yes, I've kind of mentioned, for motorcyclists, there's really nothing out there that says, you know, here's kind of how you go about running the crash test, or here's kind of the standard. Here's what speed you want to hit it at, angle, you know, what should you use? Should you use a kind of test dummy to simulate a rider, clothing, all those types of things that we just don't have any guidance on. So that was kind of part of the project, is we had to kind of give some consideration to that, essentially come up with our own kind of testing mechanisms and requirements. There has been some, you know, kind of test standard development on the European side, kind of from their community. Again, that's been only focused so far on sliding impacts. So, you know, if there was some information we could kind of utilize and kind of work with them on. But, you know, as far as the upright impact, there's a lot of stuff we kind of had to kind of learn and come up with. So just kind of a general, you know, what we kind of did is we came up with, again, some design concepts, reviewed them with TxDOT, you know, wanted to give consideration to designs that are going to be, you know, cost efficient, you know, fairly easy to install and retrofit. So we came up with a variety of different ones and kind of had some discussion with TxDOT Design Division on, you know, which ones they maybe had preference towards or we thought might have better chance of success. You know, one of the tools that we get to use here is simulation. So we can kind of simulate the impact, see how it might work before we go to the full scale crash test. Again, especially with something like this where we just don't have a lot of familiarity, it's something very new. Having those simulations kind of help us learn before we go out to run this full scale crash test. Was kind of a pretty neat tool that we got to use throughout this project. So again, we came up with a number of design concepts, all kind of different in nature. Obviously a lot of them had their advantages and disadvantages. This is essentially, from a design concept, what it actually looked like when we installed and tested is a little bit different, but kind of shows it more or less what we end up doing. What we wanted to do is again, kind of have, I think, again, protection along the top there from those kind of sharp edges of the steel post and then the W beam. We basically put this kind of top cap rail along the top. It's continuous all the way down the length of the guardrail, or at least where you would want to maybe install it. And again, it kind of provides that kind of protection along the top. And then in that kind of sliding configuration, looking at just having essentially just a steel plate down there, again, kind of help protect the steel posts and kind of prevent any interaction with those blunt objects and have redirection there if you had a sliding impact. So again, one of the tools we used kind of throughout this project was simulations, and again, we can get it pretty detailed where we can include actually different types of test dummies and include helmets and things like that. So one of the things we looked at and we're kind of focusing on, we did it, I'm only showing one example here. We did this for the upright scenario. We looked at kind of different ways to impact and angles and speeds. But primarily we're looking at, again, are we getting kind of a smooth redirection? Are we preventing arms and the head and other kind of components and limbs from maybe catching on a post, a block out guardrail, top of the guardrail when we're doing the upright scenario? So it just kind of is a neat little tool that we can kind of look at all these different things. And again, trying to kind of have some confidence before we go out and run crash tests and make sure we have some confidence in design. So you can kind of see here, this looks maybe a little bit different than what I was initially showing. So this is where we can go through and have some design iterations, make any changes we think might help it, and then go out on the crash test. I'll just say with this project, we kind of went through some back and forth iterations, simulations, testing, and kind of back to simulations. Just, again, kind of some of the things we had to learn along the way as we ran the crash tests and kind of saw things, because we certainly know what we kind of do in the simulation world is not going to be perfect, and we're making a lot of assumptions. So we had to kind of learn where we maybe made some mistakes and where we might have to do things differently.
So for crashing, we should lay down on our backs.
And just
That's a great question. Yes, and that's again, one of the things we learn, or what's done in the European testing standard, is they have a person sliding on their back head first. It's kind of those things. Is that common? One of the things we try and do with the crash test is what's the worst case. So obviously there could be a number of scenarios, but is there one that if we think and we test it this way, that hey, if this works in this sliding configuration, might be okay for other ones. One of the ones that's kind of been recommended is maybe more like a seated position coming in, just because you might have more interaction with like rib injuries. So that's one that still needs a lot of thought, but yes, we did run the crash. I'll show that video here in a little bit.
That's a lot of times.
Again, you guys see some images here. So what that kind of looks like in the actual, we installed out here on our runway aprons. You can kind of see how that cap rail just kind of goes along the top there, kind of provides some continuous protection. Again, trying to keep those sharp edges of the post and the rail itself from being able to interact with the rider. It's just kind of a pretty standard steel plate that you just kind of have to bend a few different ways when you fabricate it. It basically attaches on the backside, and then you can kind of just tuck it in front of the W-beam guardrail there. How that rub rail looks from the front side, again, kind of continuous along the bottom there, trying to provide that protection. I'll say here, we ran this particular system with wood posts. I will say actually through our pooled fund, we did another test with the steel post version. We just wanted to make sure, because there's a number of different ways that these can be installed on guardrails. Wood posts and steel posts are both pretty common. So we ended up testing both configurations. But this one in this picture just happens to be a round wood post. One thing you'll kind of note there with that bracket is that we have it offset from the post. Part of that is we wanted to kind of prevent any serious kind of, again, blunt kind of potential impact if that rub rail were to kind of wrap around the post. So we have it, it's about a few inches offset, so you can have a little bit of movement of the rub rail. You'll kind of see it in the videos I showed here in a little bit, but that was kind of the intent there of that rub rail bracket. Quick question.
Yeah, is there, I'm looking at the design and it's better than we see in most places. However, it almost seems that the design it's a brutal design in that it's not going to dissipate energy based on what it's interfacing with first. For example, a rider, a motorcycle, optimistically, maybe 1,000 pounds. So that should be able to slow or dissipate that energy. Clearly, there's a car. The car will just just hammer that thing. So it's almost as if like it's having a 2-part, but still a 1-part design, And then I think would make replacement easier as well. So I don't know if you're looking.
No, yeah, that's a great point. And kind of one of the challenges we face is that, we were working with something that's an existing design that is more intended for vehicles. So it's just gonna be a lot stiffer. So if you hit it with the motorcycle, it's probably not gonna move at all. So you're not really getting a lot of the energy dissipation, which is kind of the intent behind these hardware designs when we impact them with vehicles. They're, deflecting, they're dissipating energy. From a motorcycle perspective, again, you're not going to get much. Maybe you'll kind of see in the video, you might get a little bit with how this rub rail moves, but especially when you're on the bike still and you're impacting the upright, I would say we didn't see much. So as far as, what could be done differently, again, maybe if you're talking about starting from scratch and coming up with a new design, there probably could be some potential to give more consideration to that. Again, if you particularly have a problem, area or particular roadway that's maybe severely, has severe curves. I know that there is one in North Carolina that kind of has, severe curves, mountainous area. And so when you have areas like that, maybe you can kind of install something, is maybe has more potential for motorcycle impact. I certainly think that would kind of be a potential kind of next step, kind of looking at, okay, if we almost start from scratch, ground zero, could we come up with a design that could maybe be energy dissipating for all different types of vehicles, not just passenger cars, and then we're just making something really stiff that motorcycles have to deal with.
Yeah, and I'm not trying to be silly, he's on the right track because it's like, let's be sure that we've assumed our torpedo position. But at the same time, it's like, wow, we have a lot of recycled bottles that collapse, take the caps off them and just fill them up and make these tubes and just lay them in front. And if you run into it, well, it's better than if you were to hit it straight on.
So I know that there's a couple of designs, and I think one that was installed in North Carolina that's kind of more rather than steel. I think it incorporates more deformable materials, plastic. So I think there's kind of movement, or there's kind of ways that we're trying to kind of move that needle towards that. So, but no, those are certainly good points and things I think we need to kind of keep working towards.
Even one more question.
Yeah.
Have y'all considered how that might keep debris on the road? And cause it's on the ground, and a lot of these roads that I would think that these would be needed, like the Twisted Sisters, it's there because like you said, there's a cliff on the other side. And so there's not much of a shoulder, and any debris that would normally be kicked out and go underneath the guardrail and never could be seen on the roadway again. That looks, with that design, with it almost or at the grade, it would interfere with the natural collection of debris just being dissipated into the house.
Yeah, so with this particular one, the way we installed it where there was like an inch, but when you're actually in the field and you have variance in the grade, there can be a lot of areas where it's pretty much at ground level. Yeah, that's something that I think, maybe as TxDOT starts implementing this, kind of seeing where there's maybe issues like that, that's something we kind of try to see how high we could get it without it kind of being a problem. Because one thing
that's what I would think would solve the.
Yeah, one of the things that we kind of ran into is that if you start going higher, your slider, anybody's sliding actually went under the rub rail. So you kind of want to have that balance act. So, we felt we couldn't go very high. So, we only got 1 inch of clearance. But yeah, so, I don't know, maybe as kind of TxDOT starts working with this and seeing how it does, if there is things like that. there might have to be some kind of solutions we kind of help come up with to kind of deal with that, so.
How long are those panels before they're
I
bolted?
mean, so the idea would be is that, especially if you kind of have, we work with TxDOT to actually identify some high-risk areas where we've seen, higher number of motorcycle collisions with guardrails. So, if they're putting them in those areas, they're probably gonna be pretty far, maybe along, most of the length of the curb, and they're gonna kind of terminate the rub rail, the cap rail. So, it'd be probably a good amount of distance that you could have some debris pile up if that were kind of an issue.
So we had a question online from Hank Waters, is how much energy did you estimate it would or could absorb or dissipate?
We didn't necessarily have like a direct number we were like aiming for. Obviously, one of the things that we did do, which I don't have a lot of information in the slide, it's kind of all in the TxDOT report, is when we ran the crash test and the simulations, we actually used a instrumented hybrid 3 dummy. So we can measure acceleration loads, forces. So we looked at loads in the head, the neck, chest, legs, and we generally kind of had some criteria we were trying to kind of evaluate against. Again, some of that came from what's used in the EN13 or the European standard. Kind of just general criteria that are going to be, if we keep it below this, should lead to a non-serious injury. So we weren't looking necessarily at specific energy dissipation, but we were measuring injuries to a potential rider just to kind of have some idea. Is this, obviously going to still lead to a severe injury if they would interact with this, or is there maybe potential we keep the injuries, at a lower level? I will say again, maybe when I show the video here, you'll get some, injury dissipation with how this system interacts. That bracket actually ends up kind of collapsing. When you're impacting in the upright scenario, you see everything barely even moves on the guardrail. It's pretty much just all the motorcycle rider itself. So I don't think we were counting on a lot of energy dissipation in that particular impact. I think the primary goal there was to see, do we have any kind of limb or kind of arm interaction with the system? Do we, have any limbs that the dummy kind of break or detach? Any kind of what looked like. So it's more kind of visual inspections. Again, it's kind of the first step, that was kind of what we were looking at. I think there's a lot more we can do there. I'll just kind of show this first video, and I'm sure there'll be more talking points about it. But again, this upright scenario, I don't think I have any kind of close-up pictures of the guardrail itself after the test, but you can kind of imagine there's just not a lot of movement. We didn't really move the posts at all. We didn't, really do any kind of damage or deformation to the cap rail itself, other than maybe some minor deflection. I'm going to show after this the car and truck test, and you'll see obviously the complete difference. And I think to the point that was kind of be discussed earlier, the challenge that we're kind of dealing with trying to design something that's multi-vehicle, safe for multi-vehicle users. But as far as what we were trying to accomplish, again, we wanted to see that primarily there wasn't any kind of anything of the rider itself. And again, what we used here is an instrumented hybrid 3 test dummy. We just want to make sure that there's nothing in this particular test configuration that, kind of caught on a post, caught on the top of the rail. I'll show some pictures afterwards or here later of the actual kind of dummy afterwards, because we wanted to look and see was there any kind of tears in the leather. Again, for this particular test, we kind of make some assumptions, and we're kind of following a little bit of what the European testing standard does, where we put some standard leather gear on there. We did use the USDOT approved helmet. It's kind of just the base configuration. Obviously, not every rider's gonna be wearing that, so we kind of have to have some kind of starting point and then figure out maybe again what's kind of worst case that's also still practical to achieve a kind of safe design. I'll run this kind of one time. So, just as kind of a just interesting thing is that, when we run these tests, we were actually pulling it with the tow truck. You can kind of see that piece there that's kind of flying in the background. So kind of looks like these little training wheels on the back. But that just allows us to kind of pull it up to speed, can keep it stable so that it stays completely upright right before it hits the guardrail. But again, in this kind of particular impact, you can kind of have this scenario where maybe you slide along. There could obviously maybe at a higher speed. We did this one about 37 miles per hour, 15 degrees. Higher speed, you might actually vault over the guardrail. So there's, probably some potential for that as well. But, you can kind of see that interaction, leans on the guardrail, slides along, and it kind of ends up falling kind of off on the side. So you know, in this particular impact event, what probably the worst thing is probably actually maybe hitting the ground at this point. But, you know, it just kind of depends on all the different types of ways it interacts with the guardrail system. You can see the motorcycle there, you know, just kind of a few kind of different things there. Particularly looking at the actual instrumented dummy afterwards. So again, you know, we kind of have it covered in full leather gear. It's a little bit hard to see there, but if you kind of look along on the picture on the right, you kind of see quite a bit of debris along the rib cage. But when we looked at that area, you know, we at least didn't see any. That was kind of where it was leaning the most along the guardrail. We didn't see any tears in the leather. You know, obviously if it had torn through the leather and torn, you know, through that kind of dummy flesh, that probably would have been something we would have needed to kind of give more design consideration for. But at least from that perspective, you know, we didn't see any particular tears or snagging. Obviously, there, you know, we're measuring the force to see how much that injury would be. Again, just kind of jump into the next one, the sliding case. So, you know, as we mentioned, we're kind of dealing with just a very particular configuration. Is this the worst case? You know, I think we probably need to get a lot of action, you know, if it is or not.
Yeah.
Again, this is kind of what's done more on the European side. So we kind of more or less just copy and pasted a little bit of what they were doing. Just kind of a starting point to see how it would do. But you can see there's a lot of movement here of that rub rail. So whenever you're kind of moving things, and I don't think I have a particular video of it, but we had a video on the backside, and you can see how that bracket collapses. It starts to wrap around the post. So in comparison to the upright test, you get a little bit more damage to the actual rail, which just means we're getting a little bit of energy dissipation. It's not much, certainly. You know, one of the things is we actually started with it. It does have a bit of an incline to it. You know, we looked at different ways, having it flat and inclined. We saw that this just kind of helped. We were seeing some really high forces in the neck. We were keeping it flat. It's just kind of more of a pretty stiff bending to the neck. So this just was kind of a way that we thought, you know, if we put a little bit of incline, you kind of change the way the dummy kind of rotates coming out. We wanted to try and keep it on its back throughout the event, which we did here. But, you know, again, there's just so many different ways that we can kind of go about trying to help in one way, you know, as far as maybe specific injuries we're trying to avoid. But it's all kind of a bit of a balance act, as we kind of found out. Just a couple of pictures here. So, you know, again, you kind of see the helmet there. You know, one of the things it kind of, I'm pretty sure in this particular, we did a couple of sliding tests. Sometimes the way these dummies are designed, they have a specific shoulder connection that isn't designed to take a lot of load, not to kind of indicate that you would maybe lose an arm, but just because when you kind of bend those things, they're hard to replace, particularly with the way these test dummies are designed. So sometimes we'll see the kind of arm loose and maybe disconnected, and we can kind of look and see exactly maybe what fracture, if that's kind of the actual piece that's meant to fracture, if it was something else. And this particular one, it was kind of the piece that's meant to fracture. And then again, I'll have a couple more slides here, and then we have a couple more questions if there's time. But you can see, you know, we wanted to again make sure that these additions or these changes wouldn't necessarily negatively affect the car or the truck test. You know, when we're looking at these tests, when you have something like a rail on top or a rail on the bottom, sometimes those can kind of create a little bit of an issue we've seen over the years with like wheels catching, and then maybe the vehicle spins out funny. That wasn't the case here, which was great. You know, pretty smooth interaction. I think it kind of just pushes down the rub rail and then exits the system. But you can see how much movement we get just from a car hit. You know, you're pushing on the post, completely kind of disengaging that top rail. So again, when you're talking about, you know, the different levels of energy we're designing for, it's a very broad range when we start to include something like a motorcycle rider. And then on the high end, you know, obviously a 5,000-pound pickup truck is going to put the most amount of movement in there. You know, with these are kind of the high end of the loading scenario. So we want to make sure it's strong enough to contain a redirected pickup truck. That's kind of the primary design goal for these. And again, here, kind of slow motion, you'll see just, again, a lot of movement. We actually fractured, completely broken some of those posts. I mean, those are, I want to say, 1.5-inch diameter wood posts. So those aren't small by nature, certainly. So a lot of load going into those. But, you know, again, as far as how the design performed for all the vehicles, you know, at least for the standard vehicles, you know, didn't really cause any negative kind of concerns there. So there's a lot in that, you know, again, kind of went through a lot of different kind of, it was a big project for us, certainly. trying to have something that working with the current design, can we make it a little bit safer for motorcycle users and these different types of impact scenarios? How do we evaluate that? We have testing standards, that was kind of something we were up against. So, I did include in here, we did look and measure injury criteria, trying to make sure that, some of the different possible injury mechanisms wouldn't happen. We looked visually, so a lot of that was considered. And that's kind of what TxDOT's now trying to implement into their standards. But again, I would say it's just kind of a kind of first stepping stone. I think there's a lot more we can do from a design perspective, more energy absorbing. But again, depending on the application, when you have multi-vehicle users, it ends up being a balance act. Again, there's a lot more we're doing on this. I will say there's a national study that's going to look at actually developing testing standards. So that way, anybody that's designing something can kind of have a specific nature or way that they're going about testing it. That's going to include a lot of consideration for things like, how should the rider be sliding in? Should it be head first? What's most common? Maybe in these types of crashes, what's typical for riders, but also maybe worst case scenario. So if we, again, kind of the approach we tend to take when we run these crash tests, when we pick the impact speed, the impact angle, when we're running the test is, what's the worst kind of case scenario that's practical, and then anything kind of below that, we would, probably consider or hope that it would work for those as well. That may not work exactly for motorcycles, so that's something to kind of consider, but that's the general approach for standard vehicles. So, any more questions?
Questions and comments.
Yeah.
First of all, thank you. I mean, this step in the right direction. I mean, let's not, minimize that. But I was then curious, has anyone spent time at this is gonna sound funny, at a racetrack where you see guys going low side, high side, and, interaction with the course and, how their bodies actually are flailing around? Because to think that, I think some of us who have ridden, to think that your body assumes a perfect projectile shape, from disengagement from the vehicle, that doesn't happen all that often. It's like, it's a holy cow moment,
Yeah. No, I'm not aware of anybody kind of looking specifically like racetrack stuff. So I think we've kind of focused a lot of research and information on just, what are kind of happening in general crashes, but I think there might be something certainly.
The number of combinations is endless, and that's the problem. You can't just run through every possible scenario. That's why it's a testing standard. It considers one case. And so that is the standard, and it's a starting point. Yeah, because everything else is, car crashes don't happen at 15 degrees either. So, but that is the standard for that.
It's almost as if when you're looking at this, it's like, okay, what's the primary objective of the barrier? And then from there, all right, if the primary objective of a barrier is just to contain everything in the roadway, that's one thing. But is it to absorb, dissipate energy? And then you have two levels of dissipation that are required. I mean, it gets really, I can see how it gets complex. But, just trying to spitball some, where else could you look and see and find stuff?
I know that there's been some also stuff where they put like a pretty significant foam or protective padding on the post itself. But then that's more of a kind of singular object. If you wanted to keep, again, that idea of keeping something contained, you're not really accomplishing that goal as much. And then you also have to consider if, you're impacting an upright scenario. So I think there's kind of things that are kind of being done slowly, and that we just, how can we expand that? Can we consider, again, those range of impact configurations as much as feasible, that's realistic. And so that's, I think, where we're trying to go.
Hey, Kathy, you had something?
Yeah, actually from online, it was how well did the simulations match the physical instrumental testing?
I will say, generally speaking, this is where we went through a few, one of the things is we went in running simulations without what we always like to have is something we can kind of compare our simulations to that's a real world event, so a crash test. We kind of started out without that, so we're running simulations, again, using stuff that maybe we've had some familiarity with as far as models and, helmets and things like that. But I think along the way, we kind of observed some things that weren't really accurate in our models, that we made some changes based on some initial crash test results. And again, it's always, whenever you have more data to compare and validate against, the better. One of the areas I think we saw, and this is why we had a specific interest in doing some helmet testing, is that the helmet we were using in our model maybe seemed to have maybe more energy absorption than what was in the crash test. We just kept seeing higher forces, particularly in the axle, like a compressive neck force. We kept seeing higher values in the crash test than the simulation. There could be other things in that, and there certainly probably are, but one of the things that we felt that was worth investigating is, okay, we actually used 2 different DOT approved helmets. How much do those vary in their performance in this type of impact, or maybe you're sliding in, or you're maybe coming along the top and maybe having some interaction there. So one of the things that kind of came out of this particular project that has resulted in some additional research is wanting to understand a little bit more how these helmets vary in their performance. When it's just maybe you have like 3 different types of DOT approved, maybe you have a level all the way up to Snell. So that's one thing we're looking at, and that's one thing we kind of learned is the simulations didn't seem to quite match up in a particular injury mechanism. I think there are other things we're looking at, but one of the main ones we had at least interest in was, how's the helmet model? How are helmets just in general? Again, we ran crash tests with, a couple different types. Are those all the same performance-wise, or is there a lot of variance? As much as possible, you kind of want to have that variance removed, at least in the crash test setting. So that was kind of one thing we saw, particularly with simulations comparing to the crash test.
Any other questions from the chat or anybody else?
Great information as always, and the presentation was much appreciated. So thank you.
Thank you. Good job. Appreciate it. All right, the last items on the list there are open forum with 2 questions for you. What events or efforts are happening in your area? Be sure to send them in, let us know so that we can spread the word and get other people involved and make your event bigger and more of a success. Also, what topics would you like to hear about in the future next meeting? So if you are inspired by something that you saw or heard today, put that in. And then also, if you just go home and you sleep on it, then you wake up tomorrow with a great suggestion, please send it in to Kathy or as well. And with that, ladies, you have anything else you want to add or make sure that everybody remembers? A reminder that the just like your taxes, award nominations are due April 15th. No need to send a check, or, so it'll be a whole lot less painful. Anything else from the audience there? We're here.
We lost a rider Friday out in West Texas, strike for the Javelina. And between the time of the incident and the time that he was in a medical facility, he had taken us approximately 3.5 hours. We don't have the findings yet, but isolation. Everybody, we're pretty serious discussion going on in our club right now. And locators, I think there's going to be, at least in my organization, there's going to be a huge uptick in the number of people carrying emergency locators. West Texas is a big place, and a lot of it is not covered.
Yeah, one trip to Big Bend will assure you that
this is
there's
actually
a lot of nothing out.
This is actually on 118 between the observatory and Kent, about 12 miles south of Kent. And there were only 2 riders, neither one of them had a communicator. And it was almost 30 minutes before another vehicle came down the road that the other rider could send, and that vehicle had to go all the way to Kent.
Right.
In the cell coverage, so let's get this conversation going about the importance of locators.
Question on that, is that locators, are we using cell towers? Are we using, what kind of locators are you talking about? What kind of locators are you talking about? Something that use cell towers?
They're satellite communicators. Sharman makes them, Zumo. There's a bunch of them on the market. The best discussions that were on the adventure rider formats. Basically,
What's for GPS?
they can either be carried on the motorcycle, up on the handlebars, or in case you get separated from the motorcycle, they're also small enough in some cases to be carried on your person. Now, this is a thing if you're conscious and you can hit the button. If you aren't, I mean, nothing's gonna happen then. But the main deal is, and some of them also will trigger their own alarm from rapid changes in physical parameters. High stop, fast, impact force, things like that. The number of products on the market right now are a plethora of products compared to what there were 15, 20 years ago. Everybody really needs to look into them.
You have your hand raised? Go ahead, Nikki.
Yeah, so I'm new to the group, so I'm Nikki with Boundless Rider, and we are an insurance provider here in Texas, and we actually just launched our Safe Rider program, which through our Ride smartphone app, it has an automatic crash detection and 911 coordination feature in it. So it's all done through the smartphone app. So it detects when that crash happens and then helps to get those emergency services dispatched to the location. So this might help in
In the areas that
in
we
this
have
area.
coverage. When you get out in West Texas, unfortunately, as we know, that there's a whole lot of nothing and a whole lot of non cell phone signal places. But yeah, something's better, and it does work in where most of us are most of the time. But as you start to adventure out into the great back roads adventures, you do tend to get into less and less.
Yeah, a lot of these
connections.
communicators, especially the Charmin line, will also allow you to set up, you can have canned messages, tracking, texting via satellite. There's a lot more to them than just an SOS button. So they're well worth looking into. And one other thing to go along with that, you'll find that the choices in this thing are becoming unbelievably varied. And one of the reasons I know I have not carried one up until now is I still haven't figured out which one really suits my needs. And one of the guys in my club defined that problem. It's called analysis paralysis. Not making a decision because there are too many things to decide.
Too many
You
choices.
just finally have to roll the dice and do something.
Same thing for dinner. Too many choices. What are you gonna do? All right, so yeah, it can happen. I'm wrong. Go ahead, Kathy.
Jane also shared that the iPhone now has GPS connection if the person stops immediately. So
That is on one of their commercials, I believe, crash detection, so.
It works.
Well, I wouldn't know, and I hope not to.
I don't.
I didn't say you did.
Well,
You
no,
knew someone
I
who
didn't say it
did.
was in an
Yeah.
accident, not motorcycle.
I heard of somebody, a friend of.
And we got notified on Life 360 that it was
Yeah.
detected he was in an accident.
Yeah, I might not, but hey, you know what? My wife may test this out. So, she's
throw
not
out
here.
the
to hear
window,
that.
throw the iPhone out the window and see if it indicates it stops.
I'd be happy to do that because I don't have an iPhone. Yeah, I have kids. I have two of them. I have two test samples ready to go.
What are you doing testing crash protection?
Their phone. I'm willing to throw their phone out the window, I'm sure. So, all All right, yes, sir.
Cody Stewart with TTI. We have a project called Unlicensed to Ride, and right now we are doing surveys, paid surveys. So if I have any rider schools online, you should have actually received an email from us already. If you haven't, you can reach out to me or Laura and Kathy, and they can forward your email over to me. But we are offering paid surveys that if you are registered for a class, but have not yet taken the class or the online portion, they can take a before survey, and then after the class, they'll take an after survey. And there's like $40 in Amazon gift cards that we are offering for those 2 surveys. So if you're a rider school and you're interested and you haven't received an email from us, get with me or forward an email to Kathy or Laura, and they'll send it to me and we'll get you squared away.
Or if you're a potential student waiting to come, Laura, no names, but yeah. So, yeah, just remember that. So you can.
TTI employees are not eligible, but.
Yeah, they won't.
Stop ruining the deal. Come on, this is my plug. Come on, you know? We're trying all angles here. Come on now. Want to promote this? All right, we're gonna leave it open for just anything else from the audience there.
Thank you.
Or in the room.
To say every school owner within the state of Texas should have received an email from Cody for the unlicensed to ride, and they should have received an email from me on, I don't know, TDLR projects or something. So if you have not received any emails from either of us, reach out because we don't have your correct information.
No, it's an excellent program. The email doesn't come from Cody, just so you know, but it's one of his people in the group. So if you're confused, yes, good program, get the people involved and helps them get a little bit of money and helps us get a little bit more data on training riders. With that, I want to thank everybody for your attendance and participation today. And we don't have the date for next, do we?
It's in June, we may.
We do we have it? Did we actually say
The
it?
website, of course.
I'm looking on my calendar to see if we have the exact date. It's going to be in June.
Yeah, so we'll be looking for you in June and check the Learn Live website and it will be posted. And you'll hopefully get an email reminder if you're signed up as well.
I do. It's June 6th.
June 6th.
June
6/6, 24 though, 6/6/24.
Yes. 6/6.
No triples, just.
And hopefully they'll have the bridges room fixed by then. If
Yes.
not, we'll just immediately kick into here, right?
This is a nice room, but still, yeah.
We did.
It would be nice to start closer to that. Thank you all for your patience and cooperation today.
Thank you.
And
so
with
much.
that, we'll dismiss. Wonderful day. Be safe out there.